Hello everyone. Can you just confirm if I'm audible one more time?
Yes, sir, audible.
Okay, thank you.
Thank you.
So yeah, so I'm Kailash Prasad, PhD scholar from Nano DC Lab IIT Gandhinagar, and in today's lecture, what we are going to do is not discussing about. Okay, 1 minute. I think my screen got disconnected. Yeah. So as of now, what we have discussed in the class and all the lecture series, right? You have learned about what we call as digital design. Okay. So this is the course which we have learned, and we are in the final lecture of this course. So Professor Santanu has already shared and all the NPTEL lectures, and I hope you might have gone through all of that. Apart from that, you've done all the assignments. Along with that, whatever we discuss, I and the other TA from the ISC, uh, we try to solve some of the questions on the topics whatever have been that have been discussed in the class. Along with that, I have also tried to teach some of the concepts which are not clear to you guys. And in this lecture series, the major focus on how to understand the concepts via solving the question, right? So we have solved mostly the previous year gate question, EAC question, ISRO, and all the competitive exam question. All the questions which I have discussed over here were from these particular places. Apart from that, we have also tried to incorporate conceptual things also. In between, I've discussed many of the concept how it can be used for when we see a larger applications, right? We were discussing about memories and processor last time. The technologies also we were discussing about. In the last lecture, we have discussed about 8085, and we have solved many questions on 8085. I think that was sufficient. The other TA has also solved many various questions on that. Because almost whatever questions were required to solve the assignment was already being done. In this lecture, I would like to take the opportunity to discuss with you some of the things which might not be familiar to you, but which is highly required, right? And this lectures will be not more of a teaching kind of thing. It will be a very informative thing, because we'll be discussing about the entire system, how it looks. And if you guys face any kind of difficulty, please let me know. See, I personally work on the domain which is called as VLSI and microelectronics. So the today's lecture will be on why VLSI and microelectronics, okay, and how it is connected to digital electronics, whatever you guys have done, right? And please understand this. This is the next step for you guys, right? Because you have done the digital electronics. Now what next? Okay, so immediate next will be go and learn analog, okay, analog electronics. So many of you might be in second year or third year. You should take time to go through this subject, right? It doesn't matter whether you are a digital design engineer, whether you are a device engineer. It doesn't matter. You should understand all the VLSI related subjects or electronics related subject, right? So you should learn the analog electronics. Apart from that, there is one more course which is very important to you guys, is electronic devices and circuit, right? Because whatever we have done as of now is fully digital, but you should understand how these transistors are been made, right? How the PN junction works, how the bipolar junction transistor work, and this electronic devices and circuit. And please note, all the lectures from NPTEL are available online, right? So you can go through any of this topic at any time, electronic devices and circuit. right? Very important subject to hold your basics in the field of VLSI and microelectronics. Now, anybody knows what does a VLSI mean? Have you guys heard of this term? Anyone?
Yes, yes, sir.
Yeah, tell me. What does?
Very large scale integrated circuits.
Okay, okay. Thank you very much. So
It means
yeah,
the number of
number of.
transistors embedded in a IC is more.
Okay, okay.
That's what very large scale, no, sir?
Yeah, thank you. So it is called as very large scale integrated circuit or integrated circuit, VLSI. Okay, and microelectronics, right? So whatever electronics we are now talking about, it earlier it was called as microelectronics, but now whenever if you see any of the top research institute, including all the IITs, NITs, IISCs, or ISR, or top universities over abroad, you will see the branch is called as nanoelectronics. Okay, microelectronics is an earlier term, and it's now called as nanoelectronics. And nano, why? Because all the transistors we talk about are in nanometers, the size of the basic devices from which your all whatever you have learned in the digital electronics and gate or gates are being made are in few nanometers. Okay, in the order of 10 nanometer to 100 nanometer. Okay, so everything lies in this range, and that is the reason why the electronics devices, you should understand and appreciate how small these devices are, right? So it is 10,000 times thinner than your hair, right? You cannot visibly see the devices. And please understand that whatever chip you might see will contain more than billions of such transistors. Okay, billions of transistors. And this motivation has might have already been given in the initial lectures to you guys. Along with that, the Professor Santanu has also discussed about these things, right? What I am discussing today is how does a system actually look like? Okay, how does the system look like means, suppose if you have a laptop or you have any mobile, right? You can talk about servers you have, right? Any device which you have, what is the basic architecture of this particular device? Okay, uh, and this is like this. Okay, there is a central processing unit, CPU. Okay, then there will be what we call as memory, which is very near to CPU, right? These are called caches. Okay, then you will have your main memory. These are called as RAM. Okay, so these are actually called as RAM. And then what you will have is, and this we have discussed in one of the lectures. Okay, you might remember. Then you will have your what we call as hard drive or solid state drives, and then you have the magnetic hard drive. Okay, magnetic hard drive, magnetic HD, right? Please note that this CPU is a very small unit. Okay, very small unit, but contains say billions of transistors, right? But if you see the most of the component inside uh, your system is nothing but memories. Okay, memories. These are memories at different level. Okay, what are the caches made up of? What is the basic cell? Can anybody tell me? I have discussed in one of the lectures. Anybody can tell me what these caches are made up of? Anyone? Hello. Does anybody? Yeah, Vivek, you are right. This is SRAM. Okay. What about the RAM, which is made up of? See, these are D
Then
DRAM, okay, dynamic random access memory, okay. And what these are made up of? These are made up of flash memories, okay, flash memories, okay. And these are made up of your magnetic drives, okay. And CPU are made up of what? Logic gates, and basic unit is nothing but MOS transistor, okay, MOS transistors. You now understand that, okay, where does all the logic gate resides and where does all the other memory resides. Now my question is, and this question I've already asked, right? Can anybody name some of the companies which make processors? Anyone? Just type it out quickly. Intel and apart from Intel, IBM. Okay, yeah, that is correct. IBM has power processor. IBM has power processor, right? Intel have i3, i5, i7. Quantum processor. Okay. Who does make quantum processor? Avinash Ranjan? 10 Rife. Okay. I actually not sure about this company, but I will write assuming that you are correct. 10 Rife quantum processor. Okay. So this is something for future. Uh, IBM is the foundry which design quantum processors. Along with that, let me tell you some more companies. Okay. Samsung. So Samsung designed the mobile processor known as Exynos. Okay. Then we have AMD designed the Ryzen processor, right? You forgot one of the famous company, that is Qualcomm designed the Snapdragon, right? And there is one more company that is called MediaTek, okay, that also design a mobile processor. Now the question is, when I see this system, okay, see this system, can anybody, okay, so this is the entire system, from CPU to SRAM to DRAM to flash and magnetic drive. When I say that Intel design its own processor, which of this component I am talking about? Or IBM designs the processor, which of this component I am talking about? Can anybody tell me? Which component will be designed by Intel, IBM, Samsung? When I talk about processor, CPU, okay. Do I have any alternate answer apart from CPU? Any alternate answer? So the answer is partially correct. So when I say that I'm designing a processor, I actually design CPU plus caches. Okay. So please note that when I see Intel i7 or Intel i9, this is your CPU. This will be your CPU, right? And the rest of the part will be L1, L2, and L3 cache. Okay, and this combined will make your processor. Is that clear with everybody? Right. So this understanding should be extremely clear. When you see your laptop and you see your task manager, what are the component that has been designed by Intel? You should know. Okay, the CPU and the caches are being designed by Intel, IBM, MediaTek, Exynos, AMD, whatever company, whatever processor company you want. Right? Is that clear, everybody? Please type OK. Okay, thank you. Uh, Now, when I talk about RAM or DRAM, please tell me which are the companies who design DRAM. Anybody knows RAM? You might have seen you have your laptop, you have your mobile. It has so many GBs of RAM, but you should know, right, which company is designing that. Anybody? Who designs DRAM or RAM? Whatever RAM we say, 8 GB RAM, 16 GB RAM. Who does that? See, it has been done by Samsung. Samsung has their own RAM. Then we have Micron, right? You should know this company because in future you might be working for any one of these companies, right? That is the reason why it is extremely necessary. When I go to solid state drives, SSD, right? Again, all this company which design DRAM also design SSDs, Samsung, Micron. Then you might see SK Hynix, right? So these are the companies which design SSD. Apart from that, when I go to magnetic hard drive, right, HDD, some of the companies are Seagate, right, Western Digital. These are the companies which design this kind of thing, right? So whenever you see your laptop or whenever you see your mobile, you should understand that although your mobile is from Samsung or although your mobile is from say Nokia or Apple, not all the components has been designed by Apple or not all the components has been designed by Samsung or whatever mobile you have, Oppo, Vivo, whatever it is, right? All the individual component would have been designed by various companies, right? This is one of the important things I wanted to tell you, okay? Because many of people doesn't know. When I see a laptop, I just consider everything has been designed by Acer. It is not like that, right? Everything has been designed by say whatever laptop company you are using, right? It's not like that. Each of this individual component will be designed by various companies, okay? And please note that each of this is the thing where engineers are working hard, right, to have faster and faster processor, faster and faster memory, faster so solid state drives and hard drives. Apart from this, right, these are processor, DRAM, SSD, and HDD. Apart from this, what other important unit do you have in your laptop which I have not discussed here? Anybody tell me? Can anybody tell me? One of the very important things which all the current laptops and mobile have and I have not discussed over here. Anyone? Clock, okay. Clock is there. Speed, okay. These are parameters, okay. Clock, and these are some of the signals which are internally being generated, right? And how you generate the clock is obviously a very important task. But I was talking about a hardware that is called as GPU. Anybody knows what GPU is? Anyone? Can you type? Anybody knows what GPU is? Yeah. So it is called as graphical processing unit. Okay, graphical processing unit. So your laptop, along with whatever I have discussed, it has everything. Okay, it has processor, it has your cache, it has your RAM, it has your SSD, it also has your magnetic hard drive. Apart from that, it also have your graphical processing unit. And anybody want to tell me who designed this GPU? There are two famous companies. You might remember, yeah, Avinash, you're right. This is from NVIDIA. And the second company, any other company from which you know the GPU is? AMD, right? So NVIDIA and AMD are the biggest player. And anybody know that Intel also designed their own GPU, Intel Xe, right? Z GPU. Okay, so these are the three companies which design the GPU. Okay, GPU is a graphical processing unit. What does it do, or why do you require a GPU? Right, because right now you might want that your laptop should play say 4K video, okay, or 1080p video, a very high definition video. And playing such a high definition video, CPU is not capable of doing that, okay? For that, this kind of GPUs are required, right? Graphics, images, high quality images and high quality video processing are being done using GPU. So whenever you are playing game, okay, so many of you might be game lovers, Okay, whenever you are playing any of the game like COD, right, Call of Duty, right, or PUBG or something, if it is not banned, right? So you will see, if you are playing all of this game in your laptop, you will see your GPU consumption will be extremely high, right? And your game is running very smoothly, or your 4K video is running very smoothly. Why? Because there is a graphics processing unit which is sitting over there. Okay, so you should know about this thing. So apart from this, anything else which is there in our system? Anyone? So we have discussed about processor, caches, RAM, SSD, magnetic hard drive, along with that graphics processing unit. Consider a laptop. What does it have? Hardware, which is visible or something, anything? Screen, right? Screen it has. Okay, so you talk about display. Your screen has a display, right? So if I see my screen, it has a full HD 1080p display. Similarly, there might be some laptop which has 4K display, right? Who designed display? One of the very famous companies, Samsung, right? Samsung designed displays, right? There are various other companies who design displays. Okay, so these are some of the internal component which your laptop has. And I think if you have all of this component, you can build your own machine. Apart from that, the keyboard and the other components are there, everybody knows, right? You should know that designing a new system is not a very easy task. Okay, so you see, you require all of this processor, memories, and the displays and all, and it requires for a company to make such a system to 2 to 3 years to assemble such a system. You might see that, okay, at every year a new mobile phone is coming. Plus, please understand, to make those mobile phone, the engineers are working from 2 to 3 years. Okay, a new laptop is coming, a new processor is coming. People work hard for 2 to 3 years to give a smallest of feature you are seeing right now. Okay, so these are the various places where what we call as the VLSI industry works. Okay, so what is the reason why I had discussed about all of this different components of your system? These are the places where we work, right, as a VLSI design engineer or as a microelectronics engineer. Okay, in future, if you want to take any of the you want to continue your profile in VLSI, or you want to continue, you might want to work in any one of these domain. And that is the reason why when you want to build your profile in this particular domain, you should understand each of these things. Okay, how does it work, and what is the working of each of this individual component, right? So this was about the systems or systems we have. Apart from that, let me tell you a couple of more things, and then I will take question from you guys. Okay. So so when you want to say build your career in VLSI, right? And I have only given you the name of very few companies. There are more than 100 companies which are working over 100 companies which are there in VLSI in India, right? And if you want to make it career, right, the subjects which you should have a knowledge of, right, I have already discussed. These are digital electronics, then analog electronics, then electronic devices, right? Devices is a very important subject, because if you don't understand the basic of transistor, how will you design a circuit, right? So electronic devices. Then you have to go to a higher level and you have to learn VLSI. Okay, VLSI design. And then you have digital IC design, right? These are couple of subjects. If you can go through your NPTEL course portfolio, and if you can learn, you will have a very good basics for designing. Okay. Now the thing is, which companies you can apply for by learning this, right? So by only learning this subjects will not help you in cracking these companies. Along with that, you should have hands-on experience on designing. Okay, hands-on experience. And what you should do is you should learn the couple of this tool which are open source available: LT Spice, PS Spice. Okay, and you should be able to NNG Spice, whatever tool you are using, and you should be able to design circuits on that, right? If your university, wherever you are studying, if they have access to tool called Cadence Virtuoso, right, you should go and learn. Okay, if they have the access, right, you will find enough videos on YouTube how to design circuits. But you should know that this is a very important thing. If you want to have a career in VLSI design, this kind of tool you should use, and you design circuits. Okay. Apart from that, just how many of you are BTech student over here? Can anybody confirm? How many of you are BTech student? Right, so you can raise your hand if just I just want to know. Okay, BTech diploma, that everything is fine. Apart from other, okay. So yeah, I think one of the students has said Xilinx ISC, right? So that is also a very important tool. Xilinx ISC, Intel Altera, right? If you can use this tool, right, it will be very important for you. Okay. um, for the BTech students or and master student, if you want to have a career in VLSI, you go through all of this. You should have the knowledge of all these tools, right, to have a career in VLSI. For particularly BTech students, you should prepare for getting into top colleges, like IITs, NITs, right, IIScs, and we have couple of more good top colleges here. The masters in VLSI branch you should be aim for. Okay, if you want to build a career in VLSI, why you should build a career in VLSI? I have already motivated you guys that almost all the circuits, all the things which you are seeing over anywhere, right, will have some kind of electronics components in it. And VLSI will actually help you understand the concepts. Apart from that, almost all the IITs and IST directly allow you to do PhD after VLSI, after BTech in VLSI or any of the field, right? So you can directly do that, right? The demand for good students is extremely high now. And why I am saying like that? Because you should know that Indian government has invested around 76,000 crores, right, in the semiconductor industry in India, right? This is not a very small amount of money. Apart from that, in Dholera, right, so this is one of the place in Gujarat, right, one of the first very high and semiconductor fab is being set up, will be set up in say next 2 to 5 years. Semiconductor fabrication facility, right? After that, please note that the demand of the VLSI industry or VLSI engineers will exponentially increase, right? Because we require such highly skilled engineers, right? So this is a high time to consider this field. If you guys are interested, this is the high time to consider in this field, right? If you want to know what kind of expertise you require, what kind of things you should do, to get into this kind of field, right, you should contact me. You can write to me at kailash.prasad. I think you all might have my email ID, okay, at iitgn.ac.in, iitgn.ac.in. I can help you guys how to continue in this particular domain, right? So, any questions as of now in this regards, whatever I was discussing? If you have any kind of doubt, many of you might have many things coming on your mind, right? You can ask me. Hello, anyone? No one has any question? Avinash? Hello, am I audible? Okay, do you guys have any questions in this regards, right? Is fabrication is more important in this field, Avinash? No, it is not like that something is important or not. um, there are various steps in which things work, right? So first you design a thing, okay, you design, right? So that's what is the job of a design engineer, okay. Then you verify things, okay, that is the job of verification engineer, okay. And verification is one of the very demanded field in VLSI, because 80% of 80 70 to 80% of the time while designing a chip goes in the verification, okay, 70 to 80% of the time. Now after that, after you verify, what you make is what we call as layout, right? Whatever you want to fabricate, right, that is the job of a layout designer, uh, or what we call as physical designer, physical design engineer, okay, PD engineer, we say physical design engineer. After that, you have to verify whatever layout you make, right? And there are various steps in that: timing analysis you have to do, functional analysis you have to do, IR drop analysis you have to do, so many analysis. And the physical designer's job is to do all of that. Various kind of physical designers are available, and then what we do, whatever the final layout, this is called a GDS, the final layout which we have of the chip, this you send it to a foundry, and foundry fabricate it, okay, fabricate it, and make a chip out of it, right? So if you tell me from a company perspective, okay, the fabrication is very important, yes, because I want to obviously demonstrate whatever design I have made, it works, and you want to make a product out of it. But if a company does all of those things, which is the most important step, all the steps are important, right? And for every step you have different sets of engineers who are working. And please note, now VLSI engineers are heavily paid in this domain, right? So, did I answer your question, Avinash? Did I answer your question? Yeah. Okay. Other guys, do you have any question? Please ask. This is the time you can ask whatever field you are, doesn't matter. Do you are you a lecturer? Doesn't matter. If you are any field, and you are interested in VLSI, I can help. What is RTL engineering? Okay, so see, RTL engineering, RTL means register transfer logic, right? And when I talk about RTL designer, uh, he is a design engineer, he or she is a design engineer, right? So suppose what I want to design is a processor, okay. This is what I want to design. So RTL engineer, what it will do is he will write a Verilog code, write a Verilog VHDL or system Verilog, whatever language he is using, system Verilog code, right? And describe the behavioral description of it, right? Whoever writes the Verilog code is called as RTL engineer, and then whatever Verilog you design, you synthesize it, right? That is the job of a synthesis engineer, and then it goes on. So whatever design you are making, so suppose if you are making a processor, or the guy who writes or converts that into hardware description language code, or you write HDL code, is called as RTL engineer, right? This is, I'm talking about digital design flow. In the custom design flow, RTL engineer is the one who designed the schematic in the Cadence, Virtuoso, or Synopsys design, who make the designs. Okay, is that clear, Avinash, or do you have any question? Is that clear, Avinash? What about other students? Anyone has any questions? Anyone? See, we will have a very short session today. I think 40 minutes are already done. If you don't have any question, we would have to sign off. So this was the last lecture, right? Before signing off, I just want to tell you guys what we are doing here at IIT Gandhinagar. Okay, so you might know that, okay, various companies are working in various different very interesting topics, but as academic institute, we also work in various interesting topic, and that is the reason why you should join us, this kind of institute, right? So here at IIT Gandhinagar, we work in devices where we make very interesting devices like what we call as LD MOS, right? So this is what we call as literally diffused MOS. Yeah, this kind of transistors are used for high voltage application and high voltage applications, wherever you want high voltage, right? And these applications are automotive vehicle, okay, automotive industry, right? In vehicle, you require uh, your actions to be taken by a digital circuit, or whatever chip you are designing, but it should be capable of very high voltage. Okay, there you require this kind of uh, LD MOS. uh, After that, there are various people who are working on what we call as nano sheets, right? So you might know that the already recent technology is 5 nanometer. Okay, when you go to 3 nanometer and 2 nanometer, these are the technology which will be coming in next 2-3 years. People have this kind of transistors, right? These are not currently available in the market, but Samsung and various other companies has already started. We are working on designing of this kind of thing. Apart from that, we working on what is called as in-memory computing. Okay, so designing hardwares, or designing memories which can compute. Currently, whenever you add a hard drive in your system, what does it do? It only increases the storage capacity, right? It is just a dumb unit which just stores the data, right? It doesn't do anything with the data. What we are trying to do over here, and that's my personal, so what I do, we are trying to design circuits, we are trying to design memories which can compute, right? So maybe in future, you are plugging, say, a hard drive, or you are plugging extra RAM in your computing system. Along with the memory, your processing speed also increases, or the processing capacity of your system also increases, right? So that is the thing what we are trying to do over here, right? These are some of the very small things. Apart from this we work on hardware accelerator, where we design systems like GPUs, Okay, tensor processing unit, which can accelerate whatever workload or whatever you are running to very fast. So these are some of the things you should know. These are from devices to circuits, right? Apart from that, all the hardwares which we are designing is for machine learning. Okay, machine learning application, because machine learning is changing the world, everybody know, right? And you want to design hardwares which can run this machine learning algorithms. Okay, that is the reason why we are going for designing hardwares which can do very high machine learning processing. So very interesting works are going on here at IIT Gandhinagar and all different institutes like IITs and IIScs, right? So you should go and search about the interesting works which are going on there. If you want to join this kind of institute, right? Do your preparation and come here. If you want to apply for an internship, just go and apply for the internship, right? Try to communicate or try to go to this kind of places, right, if you have an opportunity, right? And this will help you in building your career in VLSI. Okay, so that's all from my part for today. Anything else? So if you don't have anything else, it was nice lecture series from my side. NPTEL has provided this opportunity. Khushbu has something, I have missed it. Okay, brief explanation of 8085 microprocessor. Okay, so what do you want to know, Khushbu, exactly? 8085?
So just a brief in explanation for revision, although I've studied everything, just a brief explanation that will help during the examination.
Okay, so it will take quite a amount of time if I explain 8085 over here. Let me just see if I have some slides which can 8085 overview you brief. Uh, see, so the 8085 is the one of the first microprocessors which was available, right? And please note, these are some of the important points you should know about 8085 microprocessor. Okay, uh, it has what we call as 8-bit data bus, right? And please note that this is microprocessor. Okay, it is not a microcontroller. This is one of the important thing you should know. 8086 is a microcontroller, while 8085 is a microprocessor. No, 8086 also is a microprocessor. 8051 is a microcontroller. Okay, 8086 and 8085 is a microprocessor, and it has 16-bit address. Okay, 16-bit address bus. Okay, so if you can have a 16-bit address, it means you can. What does it mean? You can go to 2 to the power 16 addresses. Okay, so you have this. Then one of the important thing is, if you have 16-bit address, you have 16-bit program counter, right? Anybody knows what a program counter does? I will just quickly tell you. It just stores the address of next instruction. Apart from that, uh, it has a 16-bit stack pointer. Okay, so whenever you want to have such operations like jump, right, and anything else, and you want to return, or whenever you have a function call, right, you want to return to somewhere, right? So whatever data you have or whatever the previous addresses you had, you just store that into stacks. Okay, stack you store, and that is the reason why you require stack pointer. Apart from that, what do we have in our 8085 microprocessor is, we have 6 8-bit registers, right, which are arranged in pairs. Okay, so these registers are BC, then HL, and BC and DE, then we have HL pairs, right? Please understand that some of the instructions only works for BC and DE pair, and it doesn't work for HL pair. I have already discussed in the last class a couple of questions, but you should know it. Okay. The 8085 microprocessor actually requires plus 5-volt supply, and it operates at 3.2 megahertz clock. Okay, 3.2 megahertz clock. So this was the general uh, overview of 8085 microprocessor. Whenever you see, okay, whenever you are come with 8085 microprocessor, these are the important thing you should know, right? What is the data bus, what is the address bit, what is the program counter. But first you should know what program counter is and how much bit program counter it is. Then you should know what a stack pointer is, how much bit stack pointer it is. Then what kind of register pair you have, what is the supply, what is the maximum frequency, right? Now moving to the functional unit, the 8085 has functional unit, right? The first functional unit which is very important, right? And this is called as accumulator. Okay, so it has an accumulator, and it is an 8-bit accumulator, right? Because all the data bus is 8-bit and everything is 8-bit over here. Okay, and this accumulator operation is accumulator is being used to perform arithmetic operation, arithmetic, then logical, IO, and load and store operation, right? And this accumulator is connected to internal bus and ALU, right? Because you want to perform arithmetic and logical operation. So this is the first thing. Then moving to the second thing, you have an ALU which perform operations like arithmetic operations like addition, subtraction, right? Addition and subtraction. Then you have a logical unit which performs and or etc. And please note that all the operations are 8-bit operation. Okay, 8-bit operation you are doing. We've already discussed about the general purpose register. We have GPR, general purpose register, and there are 6: B, C, D, E, H, and L, and they are in pairs, B, C, D, E, and HL pairs, right? Program counter we have already discussed. We have PC, right? And then we have the fifth one, we had the SP, that is called a stack pointer, right? And please understand, whenever you perform this kind of operation, push and pop, and this we have discussed in the last class. Okay, I had a question. The stack pointer will be incremented or decremented by 2. Okay, incremented or decremented by 2. Then you have what we call as temporary registers, right, which is also of 8-bit to store temporary data. And one of the important things which is very important to 8085 microprocessor are the flag. Okay, so flag is an 8-bit register, but it only have 5 flags, right? What are these 5 flags? Sign, right? S, then 0, right? Z, then auxiliary carry. Okay, auxiliary carry, I have explained in greater detail in the last lecture what each of this means. Then we have parity, P, right? Then carry, C. Okay, if I want to ask that which of these positions are there, 1 2 3 4 5 6 7 8, right? So the first D7, D6, D5, D4, D3, D2, D1, and D0, right? So it is not there, right? Here D7 is S, then D6 is Z, right? Nothing is over here, right? This is AC, right? Nothing is over here, this is P, nothing is over here, then this is CY, carry. Okay, so these are some of the important things. Moving to the next important things, and please note I am very quick having, because this is just a revision. If you want more details, you should watch the lectures and whatever we have discussed. Whatever we have, what we call as instruction register, IR. Again, it's a IR is an 8-bit register, 8-bit register, right? We have a decoder also, instruction register and decoder, right? Apart from that, the ninth thing which we have is what we call as TCU, timing control unit. Timing control unit, right? Where we generate some of the control signals. Some of the control signals are ready, right? Ready, then read, then write, something like this. Then we have some status signal, S0, S1. Then we have DMA, right? DMA is one of the important concept you should know, right? This is called as direct memory access, and it also has DMA signals are hold and etc. Apart from that, we have some reset signal. Okay, so reset in or reset out signal, reset in and reset out, right? After that, we have interrupt control, interrupt control, right? uh, how many interrupt control signals are there? There are 5 interrupt signals. The 5 interrupt signals are INTR, right? So INTR, then RST 7.5, then RST 6.5, then RST 5.5. Then one of the important signal which has the highest priority, that is called as trap. Okay, then what we have, the 11th point is serial input and serial output. serial Serial input slash serial output. Okay, you have this signal SID and SOD, right? And you will have address and data buffer and address and data bus. Okay, address and data buffer, then address and data bus, right? So if you open the diagram of 8085 microcontroller, these are the components we have. uh, so these are the 11 or 12 important things. So when you go for exam and or you are reading, please understand you should know each and every these things. It was a quite recap, very fast recap. I hope you got something out of it. If you want to go in more details, how each of these things are working, then you should go to the lecture taught by Professor Santanu. You'll understand each and everything. Okay, is that fine, Kushbu? A quick recap. I understand it was very fast, but yeah,
Yes, sir.
yeah, within the time limit, I think that was I can do. So for the final thing, right? So thank you everyone for joining all of this session. If you have friends who are learning digital systems and all, these videos are openly available online, and you should share these videos with everybody, such that they should understand and they should be able to solve questions on digital design. You should also share the NPTEL lectures. Please motivate whatever the batchmates you have to go through this field, right? And to take digital electronics, go through the digital VLSI field. You should be motivated, and you should motivate many students. Okay, thank you everyone. It was nice 12 lectures with you guys. I hope you guys have understood a couple of things from my side. Thank you. I will be signing off for a digital system lecture. Thank you everyone.
Thank you very much, sir. Thank you.